In this video, we're going to be trying to use some of the properties of exponents to help us work with problems with fractional exponents. So we're going to try this problem here first. Negative 8x to the 2/5 times 7x to the 1/3. Now, first, the negative 8 and the 7, those are just numbers. We can just multiply those two together right off the bat. Negative 8 times 7 makes negative 56. Now, as far as these exponents go, since they are x to a power times x to a power, one of our properties says that we add those exponents together. Normally, when we're doing it with whole numbers, we're thinking about how many x's we multiplied together. We added a few over here with a few over there to get how many total there were. In this case, we're going to have to add those fractional exponents, so we're going to have to think about a common denominator. Remember, whenever you add or subtract fractions, you have to make a common denominator first. So if I've got 2/5 plus 1/3, I need to make a denominator of 15 would be the easiest one, because 5 goes into 15 3 times. Just multiply by 3 to make that fraction over 15. And to get the 3 to turn into a 15, I need to multiply by 5. So I do that to both top and bottom as well. 5 over 15. If I reduce these fractions down, 6 over 15 is 2/5. 5 over 15 is 1/3. So these are just different ways of writing those same fractions, and then we're adding them together. Makes 11 over 15. So that's the exponent to put on the x. So this problem, we get a final answer here of negative 56, x to the 11/15. Let's try another one. Let's do a fraction this time. 6x to the negative 1/2 y squared divided by 16x to the 1/2 y to the 3/5. So the 6 over 16, that's just a fraction that we can simplify down. I would just think of those as 6 over 16. We can reduce that down, dividing by 2 on each level, it looks like. That would make 3/8. So I know 3/8 is going to be my answer to this one. Now, as far as the exponents go, the rule is I have to subtract the exponents when I am dividing. So x to the negative 1/2 divided by x to the positive 1/2, I'm going to have to take negative 1/2 minus 1/2. Oops, I'm supposed to say a minus there. There we go, that's a little better. Now, since these are already with a common denominator, we can just put negative 1 minus 1 makes negative 2, and then our common denominator is 2, which simplifies down to negative 1. So I could say I've got x to the negative 1, and then I do the y to the 2 minus y to the 3/5. Just like with the x's, I have to subtract the exponents there. So I put that 2 over 1, but then I need to get a common denominator, so I'm going to multiply by 5 on each layer so I can make 5 the common denominator. So now I've got 10/5, which is the same thing as 2, minus 3/5, which gives me 7/5. So now y is raised to the 7/5 power. Now the only thing that's left here is to do a little bit of cleaning up. Since we don't like to have a negative exponent, what we do is we move that to the bottom of the fraction so we can put it down here with the 8. Remember that a negative 1 exponent is just like dividing by x once, so we put it down with the 8, so we're dividing by it. And we could put a positive 1 there, but we don't need to. Then this y to the 7/5, since it's already got a positive exponent, it can stay on top, so it can just go up here with this 3. So we get 3y to the 7/5 power over 8x. Let's try one more here. Just move this up a little bit. We will do this one. 64 x to the fourth in parentheses to the 1/3 power times 3x to the negative 10th power. So the first thing that I notice is this 1/3 power is on this whole set of parentheses. Make sure that you remember that that 1/3 power affects both the 64 and the x to the fourth. So we're going to have 64 to the 1/3 power, and then x is going to have the 4 multiplied by the 1/3. Remember, a power to a power, you multiply those exponents. So 4 can go over 1, and then we just go straight across the top. 4 times 1 is 4. 1 times 3 is 3. When you multiply exponents, you just go straight across. You don't have to worry about a common denominator or anything there. Then we're going to multiply this by the 3x to the negative 10. Now, before I can do much else, I'm going to deal with this 64 to the 1/3 power. Remember that that's the same thing as a cube root on that 64, which we can look up on our table here of perfect cubes, because that is a perfect cube. That is just 4x to the 4/3 times 3x to the negative 10. Now the 4 and the 3 are just numbers, so we'll just multiply those. That's 12. And then I have to add these two exponents together. So 4/3 plus negative 10, which right now is over 1, but since it's adding, we need to change it to a common denominator. So we're going to have 4/3 plus, looks like negative 30/3, which would make negative 26/3. So that would go with the x. But we aren't quite done because we don't want to leave that negative exponent there if we can avoid it. So the 12 is going to stay on top, and then this whole thing, the x with its negative exponent, is going to move to the bottom. So we're going to have a positive 26/3 exponent on the x when we move it to the bottom. It's supposed to be a 3 there. Didn't turn out very well. 26/3. There we go. So there's our final answer. So you can see the properties of exponents apply to fractional exponents in the same way that they would to whole number exponents. The only difference is you have to remember how to do some basic fraction work. Hopefully this video has helped.